Good morning everyone. My name is M. Sharanya. I am from BSc MPCS. Now my topic is crystal structure. Introduction. Solids, crystalline, amorphous, single crystals, polycrystals. Crystal structure definition. Crystals, crystal structure lattice, point, space lattice or crystal lattice, basis or pattern. Lattice points and space lattice. These are the diagrams of lattice points and space lattice. Bravais and non-Bravais lattice. The set of lattice points together constitutes a Bravais lattice. Similarly, the set of lattice points S together constitutes a Bravais lattice, but the set of all lattice points S and S together constitutes a non-Bravais lattice. Hence, a non-Bravais lattice could be considered as a superposed pattern of two or more interpenetrating Bravais lattices. Unit cell and lattice cell parameters diagram. This is the diagram of unit cell. Primitive and non-primitive cells. This is primitive and this is non-primitive. Crystal systems, cubic or isometric, tetragonal, orthorhombic, monoclinic, triclinic, triagonal or rhombohedral, hexagonal. Cubic, tetragonal, orthorhombic, hexagonal, monoclinic, triclinic, trigonal. Cubic isometric crystal. A equal to B equal to C and alpha equal to B, beta equal to gamma equal to 90 degrees. You can see the diagrams here. Tetragonal. A equal to B is not equal to C and alpha equal to beta equal to gamma equal to 90 degrees. You can see the diagram of simple and body centered. Orthorhomby. A is not equal to B is not equal to C and alpha equal to beta equal to 90 degrees. Monoclinic. A is not equal to B, B is not equal to C and alpha equal to beta equal to 90 degrees is not equal to gamma. Triclinic. A is not equal to B is not equal to C and alpha is not equal to beta and beta is not equal to gamma is not equal to 90 degrees. Trigonal or rhombohedral. A is A equal to B equal to C and alpha equal to beta equal to gamma is not equal to 90 degrees. Hexagonal. A equal to B is not equal to C and alpha equal to beta equal to 90 degrees and gamma is equal to 120 degrees. Crystal direction and planes. The directions and described giving the coordinates of the first whole numbered point through which each of the direction passes. Crystal planes or lattice planes. A crystal may be regarded as made up of an aggregate offset of parallel equidistant planes called lattice planes. Miller evolved a method to designate the plane with three integers called Miller indices. Determination of Miller indices. Determine the coordinates of intercepts made by the plane along the crystallographic axis. Express them as multiples of lattice parameters. Take the reciprocal. Express them in terms of smallest set of integral values by multiplying the functions with the LCM. You can see the diagram here. Planes of a simple cubic lattice. These are the planes of a simple cubic lattice diagram. Planes of simple cubic lattice. Definition. Coordination number, nearest neighbor, distance, atomic packing factor or packing fraction, lattice constant. Number of equidistant nearest neighbors that an atom has in a crystal structure is called coordination number. The distance between the nearest neighbor is called nearest neighbor distance. The fraction of space occupied by the atoms in the unit cell is called packing fraction. For a cubic lattice, the interfacial intercepts are equal in magnitude and hence called lattice constant. Atomic packing factor or packing fraction. N is equal to number of atom per cell. V is equal to volume of each atom. V is equal to volume of unit cell. APF for simple cubic structures. Atomic packing factor APF is equal to volume of atoms in the unit cell by volume of unit cell. APF for BCC lattice body centered cubic structure. Unit cell close packed directions. Length is equal to 4r by under root 3a. Contains 1 plus 8 into 1 by 8 is equal to 2 atoms by unit cell. 1 of 4 close packed directions. APF for an FCC lattice face centered cubic structures. You can see here the diagrams and crystal structure NaCl. The previous lattice is FCC with the basis containing 1 sodium and chlorine ion. Since the structure is symmetric, the chlorine and sodium ions positions can be interchanged. The coordination number is 6. Bond length is 2.82 angstroms. You can see the diagrams. Crystal structure diamond carbon. Crystal structure of diamond is FCC with the basis containing 2 carbon atoms. The coordination number is 4. The bond length is 1.54 angstroms. X-rays. X-rays are electromagnetic radiations of wavelengths varying from 0.01 angstroms to 10 angstroms. Since the dimension of the atom is of the order of few angstroms, crystals provide an excellent facility to diffract X-rays. There are two kinds of X-ray diffraction: Low diffraction and Bragg diffraction. Bragg diffraction or reflection. You can see the diagrams here. Bragg's X-ray spectrometer diagrams also you can see here. D is interplanar spacing and lambda is the wavelength of X-rays and pi is the glazing angle, n is the order of diffraction. Thank you so much.